Hello everyone, welcome back to the lecture series on Foundations of Deep Learning, Concepts and Applications. In my previous lecture, we have discussed about LSTMs, their architecture and working. In today's lecture, we will discuss about gated recurring units, which we call as GRU. The contents for today's lecture are Introduction to GRU, Architecture of GRU, Gates in GRU, Applications of GRU, LSTM versus GRU. So, first we will start with the motivation for gated recurrent unit. What is the reason for the discovery of GRUs? So, we have seen RNNs. These RNNs were essential for sequential data like text, speech, time series analysis, etc. They can't capture long-term dependency due to vanishing gradient problem. To solve this problem came LSTMs, the long short-term memory, which solved the problem of capturing long-term dependencies using complex structures with 3 gates, the forget gate, the input gate and the output gate, but it increased the computational cost. To reduce the computational cost came into picture the gated recurring units or recurrent units, which overcome this problem of computational cost, and it uses LSTM architecture by merging its gating mechanism. So, it uses the LSTM's structure, but it merges 3 gates into 2 gates. So, we will see how GRUs work. Okay. So, we will look into an example, a sentence like, my grandparents live in Germany and I visit them every summer, which is why I understand German quite well, but I am well versed in English as well. So, in this sentence, if we see that there is a relationship between Germany and German, and there are a lot of words in between Germany and German, but after the word but, the context changes. So, after German quite well, but I am well versed in English as well. So, at this time I don't require to remember the terms Germany or German. So, the context here gets changed. We will just have a look. So, till this point, German and Germany, they were having a relationship. It was important for the sequence to memorize or have it in mind that there is a term Germany here, because it is related to the language German here. But after this one, I am well versed in English as well, doesn't require your memory of Germany or German. That means to some portion of the sentence, you require the memory to be there. After that, you don't require it. So, this is done in GRU. So, like LSTMs, GRU is designed to model sequential data by allowing information to be selectively remembered or forgotten over time. Okay, so that is done in GRU. So, similar to LSTMs. Now, this gated recurrent units was introduced by Chow et al. In 2014 in the paper Learning Phrase Representations using RNN encoder decoder for statistical machine translation. Okay. So, that is the original paper where GRU was introduced, and then we will see the architecture of GRU, what exactly it is made up of. So, this GRU has 2 gates. In LSTM, we had 3 gates, the forget gate, the input gate and the output gate. In GRU, it has 2 gates, the update gate, which we call as ZT, and there is a reset gate, which is RT. Okay. So, let us see if this is my black box for GRU, what exactly comes inside that box. So, there are 2 inputs, HT-1, which is the hidden state from the t-1th instance time instance, and xt is the input from the tth instance of time. And these 2 inputs go through 2 gates called as the update gate and the reset gate, what is the function of these gates? Reset gate determines how much of the past information it needs to forget, whereas update gate determines how much of the past information it needs to carry forward. So, that is the function of reset gate and update gate in GRU. Unlike LSTM, GRUs does not have a separate cell state. It has only one hidden state HT. So, together with the gates, it has a hidden state also HT, but it does not have a cell state. Now, architecture of the reset and update gate. What exactly is there inside the reset gate and update gate? So, we will look into this picture and we will see where exactly the reset gate is here inside this picture, where is the update gate and where is the hidden state here. So, if we see, let us look into this one. This is my xt and this is my ht minus 1. Now, both these things are going and it is going in a sigmoid activation function, function. So, this RT that is coming out after the sigmoid function is given by sigmoid working on ht minus 1 xt's weighted sum with the weighting matrix being WR. What is WR? WR is the matrix associated with the reset gate, okay, and then whatever comes out of this sigmoid operation, this RT gets element wise multiplied with HT minus 1. So, HT minus 1, it is getting multiplied here. So, we get RT into HT minus 1 here. Okay. Now, this is my reset gate. Now, how exactly the reset gate is working? So, this sigmoid, as I told you before, it gives a value, or sigmoid operation gives a value between 0 and 1. Now, this 0 and 1, any value between 0 and 1 means 0 means totally forgotten and 1 means totally remembered. So, any value between these two, when it is multiplied with HT minus 1, that means from the previous time steps hidden state, some portion of it is, or whatever irrelevant information was there, that is forgotten and the relevant information only is coming out in RT multiplied by HT minus 1. Okay. So, this is my reset gate. Then we will see there is something happening here as well. So, here also if you see, the input is xt from here and HT minus 1, that is also coming from here. So, these two are going through another sigmoid function. So, my ZT is given by sigmoid WZ into HT minus 1 XT. Now, what happens? This sigmoid function once again gives a value between 0 and 1. That means it is the amount which we want to forget. Okay. So, 0 means total forget and 1 means totally keep. Now, 1 minus ZT means it is the amount which we want to remember. Now, that gets multiplied with HT minus 1. If we see this multiplication, HT minus 1, 1 minus ZT into HT minus 1 element wise multiplication, which gives the amount of information that I want to carry forward. So, this is my update gate. Okay. So, it updates the information whatever I want to carry forward. Then here there is another operation that is happening, which is tan H operation. So, tan H is it is operated over once again xt from here and ht minus 1 coming from that side. So, what is my h prime? H prime is tan H of RT HT minus 1 into XT. So, XT comes from here, XT is here, and then RT into HT minus 1, whatever we have gotten here, that actually comes here, that comes here, and then it goes here. Okay. So, and WH is the weight matrix for the hidden state, and we get HT prime. What is HT prime? That is tan H of WH into RT into HT minus 1, and XT is weighted sum with the weight matrix WH. Now, if we see here, after H prime T is done, then it gets multiplied with ZT. Okay. So, this ZT is coming here and it is multiplied by HT prime. So, we are getting ZT into element wise multiplication of ZT into HT prime, and then whatever is the output that we are getting, it is a summation of whatever was coming from here and whatever is going from here. So, HT equal to 1 minus ZT multiplied by HT minus 1 plus ZT multiplied by HT prime. Okay. So, this is my updated hidden state, and this is called as the candidate hidden state, which is the potentially new hidden state calculated based on the current input and the previous hidden states. So, basically whatever new information we want to add to the previous hidden state, that is taken care in the candidate hidden state, and whatever hidden state, updated hidden state that is coming, it is having this part also, as well as 1 minus ZT into which is coming from the into HT minus 1 which is coming from your update gate. Okay. So, there are two things, reset gate and update gate. Reset gate is this part, update gate is this part, and this is basically your hidden state. Okay. So, this is the architecture of the reset and the update gate that is present inside the GRU. Now, comparison between LSTM and GRU. So, if we have LSTM and GRU side by side, the similarity is both the types of recurrent neural network layers designed to handle sequential data. So, both of them are handling sequential data. They address the vanishing gradient problem in traditional RNNs by introducing gating mechanisms that allow them to capture long-term dependencies more effectively. So, both of them are capturing long-term dependencies effectively. Both LSTM and GRU is doing that one. The difference is here in LSTM 3 gates are used, which are the forget gate, the input gate and the output gate. In GRU we use 2 gates, the reset gate and the update gate. LSTM is a more complex architecture because there we have 3 gates. In GRU the architecture is simpler because we are having 2 gates. So, as more number of gates are there, more number of parameters are associated with LSTM, and here number of parameters in GRU is less because less number of gates are there. Training time is more in case of LSTMs, whereas training time is less in terms of in case of GRU. Okay. Then the question comes, where should we use LSTM and where GRU? So, LSTMs are ideal for time series forecasting, text generation and tasks requiring long-term dependencies. So, that is the place where LSTMs are very ideal to be applied, and GRUs, they are preferred for cases where computational efficiency is important. So, LSTMs will do the same task, but the computational efficiency or the computational cost requirement in LSTM is much higher. So, if computational efficiency is important, in that case we should use GRUs. Now, limitations of LSTMs and GRUs. So, both LSTMs and GRUs, they capture the long term dependencies which is there in a sentence, but it still exists. So, that long term dependency, it is difficult to capture both in case of LSTMs and GRUs. So, what is the solution to that one? That is attention mechanism in RNNs or LSTMs. That is what we will study in my subsequent lectures. And with this one, I come to the end of the discussion with GRU. So, before concluding, let me summarize what we have learnt in today's lecture. So, we have learnt about the gated recurrent unit, which is GRU, and what is the need for GRU? GRUs are used to solve the problem of computational efficiency. In LSTMs, the computational cost is high because it uses 3 gates, whereas GRUs, they combine those 3 gates mechanism into 2 gates. So, in GRU, we have 2 gates, the reset gate and the update gate, and there is no cell state, there is one hidden state in case of GRU. And we have seen how the internal gating mechanism happens. So, we have seen how the reset gate works, how the update gate works, and what is the hidden state, what exactly is the function of the hidden state, and how the updates and reset gate, they help in capturing the long term relationships. So, it is basically till whichever time the relationship between 2 words are required, we will keep the memory till that time. After that, that memory will get discarded. Okay. So, that is how the GRUs work. Okay. And then we have seen the comparison between GRUs and LSTMs. So, LSTMs use 3 gates, GRUs use 2 gates, and they are the number of parameters in case of LSTMs are more, in case of GRUs it is less, and computational cost is more in LSTMs compared to GRU because number of gates are less here, and time taken also is more in case of LSTMs compared to GRU. Then we have seen which is the place where we should use LSTM and which is the place where we should use GRU. So, we have seen wherever the computational cost is very important, computational efficiency is important, there we will use GRUs. Other places for long, sequential data with long term dependencies, we can use LSTMs also. Okay. So, with this one, we get to know the differences between LSTMs and GRUs, where exactly to be used, GRUs, where all we should use GRUs, but still we have seen that LSTMs and GRUs, even if they capture the long term dependencies, but long term dependencies, there is a problem. So, for that one, attention mechanism in LSTMs, RNN's LSTM, that is something which is required, which came into picture, and that we will study in our subsequent lectures. I hope with this one I come to the conclusion of today's lecture. I hope you have understood how GRUs work, what is the difference between GRUs and LSTMs, and where all to use GRUs. And with this one, I conclude today's session. We look forward for meeting you all in my next session. Till that one, keep learning. Thank you.